5.6 question number 2, right?
Yes, sir.
So there is a very straightforward logic about this. We have a uniform random variable, right? In the intervals a to b, right?
Yes, yes,
And
sir.
for uniform, we have very good property. Just wait a minute. Let me open my whiteboard. Okay. Now you can see the whiteboard, right?
Yes, sir.
Okay. So x is given as uniform in a to b, right?
Mm.
So uniform has a property that whenever you choose any intervals of same length within the support, let's say this is your support a to b, right? So if you choose any interval of the same length, any two interval, let's say this interval and this interval, then the probability that x will take value inside this and inside this will be same, because these are of the same length, right?
Yes, sir.
And uniform has this property because at every point the density are same. That's why the probability at inside the equal length intervals will also be same. So now
Same.
it is given that probability x is less than a plus 2 is given, right? Some value.
0.2. Mm.
Yeah, something 0.2. So a plus 2 will be what? This is your a to b support, right? So a plus 2 will be somewhere here. So this length, this interval we are to calculate probability inside this is given, right?
Mm.
Now we are to find probability x greater than or equal to b minus 2. So b minus 2 will be somewhere here, but the length of these two intervals will be same, right? This is of unit 2 and this is again of unit 2. So
2.
the probability of this interval, probability inside this interval will be same as in this interval. So the probability here is 0.2. So again, in this interval will be 0.2, right?
Yes, sir.
Yeah.
Oh,
So no calculation are needed. If you want to do some calculation, you can do. Here it is what this is. If you write in the formula, this gonna be a plus 2 minus the lower limit, that is a, right? Upon the length of interval, that is b minus a. This is given, or you can say this is what, this is 2 upon b minus a. This is given to you 0.2. What we are to find, we are to find inside this interval, that is b minus 2, right?
we have to calculate 2 by b minus.
Yeah, again same thing you will get.
Yes. So in the same activity, question number 4.
So that question is very straightforward.
So, ma'am, answer will be directly the mu will be the answer. No?
Yeah. So the question asked you to find which value of x is most likely to occur. So you know that around the mean, most of the values clustered around. So
Okay.
that's
Okay.
the direct answer. You don't have to do any calculations.
Ma'am, in question number 7.
Then, yeah. So you have to find the uh, x is given as normal 50-25. You have to find probability x greater than equal to 50. So you know the values are again mean here is 50. So the values are clustered on 50. So if you have to find the value x greater than 50, so it is just half. If you draw the normal curve, how does it look like? How does the normal curve look like?
Bell-shaped curve.
Yeah. So that bell-shaped curve will have the center as at mean. So here mean is given to be 50. So if you like split in two parts, like the probability will be half of. That is why if you calculate the probability x greater than equal to 50, that will be 0.5.
Okay. Okay, got it, got it.
Anybody else?
Hello.
Yeah.
Yeah. Hi. My name is Neha. My doubt is regarding graded assignment 6, question number 2.
Okay.
I actually do not understand how the transformation of a variable impacts the mean and the standard deviation of the Z. So can you explain that?
Yeah, sure. So have you checked the graded solution?
No, not yet.
Okay. Okay. So I will advise you to go and see once. Right then I will just give you one hint.
If you could just explain the general concept, that would be
Yeah.
wonderful.
So see, your Z was given to be normal. I think it was, let's say it is mu sigma square. Now, if you take the fine transformation, let's say Z is now AZ plus B, where A and B are constant, then this will again be normal distribution with mean A times mean of Z, that is mu, plus the constant B, and variance will be B square into variance of Z, that is sigma square. So if so, this will be your new.
This will be all right.
Yeah. So you just have to use this and you can proceed accordingly.
All right. All right. Thank you so much.
Ma'am, is this a doubt session or revision session, ma'am?
This is a doubt session.
Ma'am, has the today's session from 7 to 9 been preponed to 5 to 7? Because that was with Professor Andrew.
No, that was yesterday's session from 7 to
But
9.
today also it was showing in calendar. That's why I asked.
Wait, let me check.
No, now the calendar is updated from 5 to 7.
Maybe some mistake then. Just give me some time. I will just confirm.
No, I mean just asking. Morning it was showing 7 to 9 was with Professor Andrew today. And now it is showing 5 to 7 and the session started.
Okay, okay. Some mistake may happen. Later.
And in the Google form, I had mentioned the topic of difficulty as Markov and Chebyshev's inequality.
Yeah. Okay. So you want to know Markov and Chebyshev?
I want these two concepts to be discussed in a little detail. I mean, with examples that will be like what happened yesterday. That was quite helpful.
Just give me some minute, 1 minute. Yeah.
So probably Andrew sir will take similar kind of session in the next week. That will have questions on week 4 to week 6.
Okay, okay.
So yesterday's session was on week 1 to week 3, and probably in the next week or day after on the next week we will have the session on week 4 to week 6.
Yes, that will be great. No, why? Because in today's calendar, in the morning, it was showing the same. That's why I asked.
No, it was scheduled only on yesterday. Andrew sir session was scheduled only on yesterday.
Can I ask one more doubt?
Yes, Nia.
Yeah, hi. So in the video of PDF of monotonic differentiable functions, there is a problem on uniform distribution. So I didn't understand the problem at all, even when Professor.
Okay. So I think if you are talking about the function mod of x or something, I think x square or x mod of x function is given, right?
Yeah, the x is uniform and you have to find the PDF of x square, but it's not a monotonic.
And uniform is given in the range of what?
-3 to 1.
Yeah. So you cannot apply that monotonic function formula here.
Yes. How do you find the PDF then?
Yeah, that's I'm talking. So first tell me why you cannot apply monotonic function formula here.
Because it's a quadratic. It goes down, then it goes up. It's not monotonically increasing.
Yeah,
So
inside that support, right?
inside that support, yes.
Okay, so there is a method which is discussed in the same lecture.
Yeah,
How
yeah,
to find PDF from a PDF of a function uh, from a given distribution, right?
yeah. I didn't understand that.
Okay, so let me explain. So here, okay, so just wait a minute. Okay, so so there are general steps to follow, right? So x will be given to you, right? Some PDF function that, let's say, this follows some PDF f of x, right?
Mm-hmm.
Now you have to find if PDF from some function of x. Let's say y is equal to g of x is any function. In that question, it is x square, right?
Okay.
Okay,
Yes.
so we have to find the PDF of this x square.
Correct.
Always follow those steps. First of all, just find the support of y, that function, whatever function is given here. Support we have to, and the x is given uniform, right? In -3 to 2.
Correct. Yes.
So support of y will be your 0 to 9, right?
Yes. Correct.
Now we have to find CDF first.
Okay.
CDF of y. This is my second step. First find support. Second you have to find the CDF.
Mhm.
Okay, CDF we know CDF is defined for all real numbers, right?
CDF is sorry.
CDF is defined for all real numbers. CDF is a function from support to real number, right?
Oh yes. Correct.
Not from support. CDF is a function uh, 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 from where to where. It is from up to real line, right?
Mm-hmm.
And the domain is what?
The values that the function takes would be the support here.
Sorry, it is from real number to 0, 1. For every real number, CDF
CDF.
is
Correct.
defined and the values it takes inside 0,
0
1, right?
1. Correct. Huh.
So here support is 0, 9 for y,
Yeah.
right? So if you see y, whenever y is less than or equal to 0, your CDF gonna be 0, right?
0. Yes.
And whenever y is greater than or equal to 9, your CDF value
1.
gonna be 1. That is clear. Now inside the support we have to calculate. So choose
Correct.
y into 0 to 9, right? If
Mm-hmm.
I define the CDF, it is defined as the probability that y is less than or equal to y.
Mm-hmm.
Right? Here y is what? Y is x square less than or equal to y.
Mm-hmm. Okay.
Now I will change into the CDF of x. That is, I can write it as minus root y less than x less than root y, right?
Mm-hmm. Okay.
But there is
Yes.
a problem for define x. This is my limits of x, right?
Okay.
This is minus root y to root y. This is my limit of x. So if
Mm-hmm.
you look
Correct.
at the support of x, it is -3
2 1.
somewhere here, some 2, right?
It's still 1.
Sorry.
The support of x is from -3 to 1.
Okay, -3 to 1. Okay, so here if y I'm choosing from 0 to 9, right?
Mm-hmm.
Is y. If y goes greater than 1, then limit of x, the upper limit of x will be somewhere more than 1, right? Because the root y of that value gonna be greater than 1, right? This is limit of x. Minus root y to root y is the limit of x now.
Yes. Yes.
If I choose
Yes.
and y I have chosen between 0 to 9. If y goes greater than 1, then the upper limit of x will be
1
outside of the
maximum.
support, because the support of x is up to 1 only.
Okay. Okay.
So that's why I'm dividing into two intervals. One is y whenever takes value in 0 to 1, and y whenever takes value 1 to 9. Okay.
Okay.
Whenever y goes 0 to 1, there is no problem. I have upper limit also, lower limit also. Okay, and x is what? Uniform distribution. So that will be root y minus of minus root y. That's gonna be 2 root y, right? Upon the total length of the interval, that is, this is -3 to 1. That's gonna be 4. So
Yeah.
this is
Correct.
true when
Yeah.
y takes value in between 0 1.
Yes, correct.
Whenever y takes value 1 to 9, this inequality, this inequality is right. P minus root y. Lower limit, there is no problem. Lower limit can be up to minus root 3 because
Yeah.
maximum value of y is 3. And
Mhm.
x less than, but the upper limit gonna be my 1.
Yeah.
Okay, now what is this probability? This is for x, right? X follows uniform. So this
Mhm.
is gonna be 1 plus root y by 4.
1 plus root. Oh, I'm confused.
That's length of interval divided by total length of interval, total length of support.
Correct. Yeah.
Okay. So
Okay.
now my CDF is what? Now CDF I have defined for all real values. For less than 0, it is 0.
Mhm.
And whenever it is in 0 to 1, it is what? It is
It
this
is
thing,
2 root by, yeah.
by 2, right? And whenever y goes 1 to 9, here you can put equality in any case because it doesn't matter. Doesn't matter. It's gonna be a continuous random variable. 1 plus root y by 4, right?
Yeah.
Am I making any mistake here?
No, no, I'm just trying to understand. It's
Y gonna
slightly
greater than 9,
confusing.
it's gonna be 1.
Okay. Yeah, that is that I'm still stuck at that 1 plus root by upon 4.
So this is my CDF. Now you can find PDF easily.
Yeah, PDF. Yeah, the problem is finding the CDF. I'm having trouble with all the functions that are not monotonic.
So always follow these steps. First, find the support. Then you have to find the CDF of y, and then you have to convert that thing into the CDF of x.
Mm-hmm.
Now look there. This step I've converted this into the CDF of x.
Yes.
These are the steps you have to follow to convert the you have to find the PDF of function of random variable.
Okay, I'll walk through the steps as you have explained myself, and then maybe I'll get better idea. I understood what are the steps.
Okay.
Thank you so much.
So any other doubts? You have quiz for week 1 to week 3 on Sunday, right?
Yes.
So if you have any doubts regarding these weeks, you can ask.
The list of formula will be made available.
This formula?
The list of formulae in for stats 2. I mean,
The exam you are talking about?
in the exam only, because
No,
yesterday,
exam, why we will give formulas?
that is what I'm telling.
No. Exam, in
Professor
exam.
Andrew said that that could be looked into as a possibility. That's why
Okay.
I'm asking.
But not for this case.
The quiz 1 only he was talking about. That's
Yeah,
why
yeah.
I asked.
Okay. So no. For this
And
case,
one more doubt. When we write a normal distribution like n mu, I mean n 10 9.
yeah.
So many cases it is the variance is interpreted as, I mean the second parameter is interpreted as sigma square or sigma, I mean as a standard.
Sigma.
Yes. So
Sorry?
No, I said sigma square. It's always sigma square.
No, why? Because in some of the examples and later in the video lecture, professor clarified that he has taken sigma in the examples, but it should be sigma square. I mean,
yeah.
so it's not mentioned in the question, and what it should be
No,
interpreted.
if it is not mentioned in the question, always take that as a sigma square. Okay.
Yeah, in one of the lectures, Professor Andrew had taken sigma square as sigma. That was just to make the calculation easier, I think.
Yeah, okay, it can happen. If you will look different books, you will see that somewhere someone just denote as a sigma that quantity, and someone just write as sigma square. So
Yes. So if it is not mentioned, I mean, it is not in symbol,
yeah,
it is in
for
number.
this course, for the purpose of this course, you have to assume if not mentioned that second parameter is your sigma square.
Okay, thank you.
So one more doubt from activity 5.5. Question number 5. Hello.
Just hold a minute. Yeah, what is the doubt there?
Ma'am, what I did was I integrated all the values like 0.1, the cx, 0.3, and added them equal to 1.
Yeah,
Then there I got c equals to 0.4.
C equals 0.4. I have to calculate.
And then I,
You didn't get the final answer?
no ma'am. Then I did that 0.3 into 2.5 minus,
I will solve here.
I was getting 0.55 as my answer.
Can you tell me the question?
Fx equals to 0.1 when x equals to 0 to 1.
And CX?
1 to 2. 0.3, 2 to 3. 0 otherwise. Find the value of p when x is,
X is between 2.5 to 1, right?
yes.
So first, in order to find this, so what is this? It is going to be integral fx of x dx from 1 to 2 plus integral fx of x dx from 2 to 2.5. So for 2 to 2.5, we know that fx is 0.3, but between 1 to 2, we don't know what cx will be. So we'll integrate it. So it will be 0.1 dx cos 0 to 1 plus cx dx from 1 to 2 plus 0.3 dx 2 to 3. 0 is otherwise, so we'll leave that. So this is going to be 0.1x, and if you take the limit, it's going to be
0.1.
1 plus this is c by 2 x square, so 1 2, and this is again 0.3. So 4, 1, this is 2 to 4 minus 1 3, so 3c by 2 equals 1. So if you take it there, so it will be 3c by 2 is equal to 0.6. So c is going to be 1.25, that is 0.4. So c is coming to a 0.4. If you substitute it here, so 0.4 times x dx from 1 to 2 is 0.3 times dx 2 to 2.5. So you minus 1, that is 0.4 is 0.3x. So 0.3 into 0.5. So this is going to be 0.15. What is the answer?
0.7 point something.
Mistake.
0. Just a minute.
Okay.
Yes, 0.7.
So the one, oh, there. It should be. Nitin, can you see if I have done any mistake?
I did the same method and answer
Sorry?
is
Can you
0.5.
check if there is any mistake?
Which question this is?
This is
5.5, question number 5.
Okay, let me see. Your method is correct. I think some mistake in the calculation only.
calculation mistake. I
Yeah.
can find it.
No problem in the that solution. Just check the calculation.
Oh, I can't find it. Okay, so the process is same only. There is some calculation mistake somewhere. Just check it. I will also check it once. Okay.
This is an open session for week 1 to week 3, or you can ask for week 4, week 5, week 6 as well. And the summary session for week 4 to week 6 we are planning in the next week. Just because of the quiz, we are not doing the summary for week 4 to week 6. So if you have done any, if you have any doubts regarding any weeks, you can ask.
Can I ask a question on practice assignment or for refresher week?
Yeah, okay.
In that question 4, I have a doubt. I got the answer, just a doubt I have.
Question number 4.
Yes.
Yes, okay.
It is A union B union C is equal to S, or the sample space.
Yes.
So that's equivalent to saying that A union B union C is equal to 1.
No, probability of A union B union C equal to 1, not the A union B union C equal to 1.
Okay. And what they have given is that the probability of A union B is 3/4.
Yeah.
And what is the value of C minus A union B?
Yes.
So in this, it's just 1 minus 3/4.
Yes.
But the doubt I had was, how do we conclude that A intersection B or A or B intersection C is not to be considered?
You are saying that 3/4, right?
Huh.
Yeah, so just look at the what is given. It is saying that at least one of the events A or B occurs, right?
Yes.
Yeah. So what does it mean? At least one of the event A or B occur.
Okay, so always either A or B will occur.
Yeah. And if it is says that both the events occurs at the same time, then it's gonna be A intersection B.
Okay.
Okay.
So this 3 by 4 includes A intersection B.
It includes A, B, and A intersection B.
Okay, okay.
Just look at your Venn diagram. How you draw the Venn diagram for that?
I'm not sure how to visualize the Venn diagram.
Okay, look, this is your event A, and this is your event B. So this part is A intersection B. This is A total, and this is B. Okay, so this part is A intersection B, and this whole part, this whole. Okay, this is your A union B. Okay, so union is consist of intersection. Okay, and you can say this is your A minus B, and this part, this is your B minus A. Okay, so A union B you can always write as A intersection B union A minus B union B minus A. And I'm doing this because these, if you look at these three all are disjoint. Okay, this is A intersection B, this is A minus B, and this is B minus A. So all three are disjoint always.
So in this diagram, if I want to represent C, that will be A union B whole complement, because A union B union C is S.
Sorry.
In the diagram which you showed, if I want to represent C also,
Yeah.
that will be A union B whole complement.
No, C is some different event. I just talk. I was just talking about A and B, two events in general, not about that question.
Okay, okay. Yeah, that one I know.
Yeah.
Thank you.
Thank you. So no more doubts, right?
Can I ask one more question?
Yes, yeah, we are always for that.
In question number 6, I may have made a silly mistake. I don't know how to get that 1 by 2 to the power of 11.
First, you have to find T, right?
I have to find. Okay. In that, okay, finding T is required. Okay.
Yeah. Okay, so
Okay,
yeah, this refresher week questions, we already have all those questions in any of assignments.
okay.
Just slightly modification in the numbers or just for any concept.
Okay. I read that T as 1.
Yeah.
That's okay.
No, that is T.
Okay. Thank you.
Anybody has any doubt from week 1 to 3? If nobody has any doubt, maybe we can take the session next week from week 4 to 6. So Sunday is your exam also, so you should study also for that. If anybody has any doubt, you can ask.
I think Nikita, we can close the session. We can have the summary session for week 4 to 6 in the next week.
Yeah, that's what I was thinking.
Because I think no one has doubt now.
Is it all right for all of you?
Yes, ma'am. I think it sounds good.
Yeah, okay. Okay, so we will have session in the next week for week 4 to week 6.
We'll schedule the session like solve with us next week.
Yeah, thank you.
Yeah, thank you. Others, do you have any doubts? Sudhiti, Samarth, Krishna. Okay, Karthik can close the session.
Okay, Nikita. Yeah.
Yeah, okay.
Thank you.